Hello. This lecture will focus more on transform plate boundary. And transform plate boundary basically is when two plates move past each other. For example, we have one plate here going this way and the other one going this way. So basically, we have here a transform boundary right here. And here we have a divergence boundary right here, another divergence boundary. And so if you look at this um, here, you'll be able to see why this is called transform boundary, this right here, this line right here. Now, let me just erase this, and then I'm gonna mark this plate right here called plate A. I'm gonna use, for example, purple for that one. That's also plate A also because they are in the same side. This is purple. And now the other one would be, I'm going to use, for example, yellow color right for this one right here, plate B. This is plate B. Now let's look at this segment right here, or this fold right here. Let me use just the white color right here. Okay, now let's start with this segment from here to here. So because we have a divergent boundary here, let me use another red color here. Because you have a divergent boundary here, this one goes this way, and this one goes this way, like this. And because you have a divergent boundary here, this one goes this way, and this one will go this way. Now let's look now at each segment. Let's look at this segment, for example, here. You can see that both this one go this way, and this one also go this way. So they have the same plate, BB, okay, and they are moving the same place, same direction. If you look at this segment right here, we have the same plate, purple, purple, and also they are moving in the same direction. However, if you look at this segment right here, I'm going to use blue color for this one right here. This one here, you can see we have purple up here and yellow here, meaning we have two different plates. And if you look at the arrow on both sides, you can see that this one here is moving this way and this one is going this way. And that's a place where this is called a transform boundary. Why? Because you have two different plates and one is moving this way and the other one moving down the other way. And basically the transform boundary, you find them linked to divergence boundary, to the ridge. They split them. So the best example of a transform boundary is San Andreas fault right here. This fault right here. And again, this is like nothing but splitting of two divergent boundary. If you have divergent boundary right here, another divergent boundary somewhere here. And basically this line here just like split this divergent boundary with this one here. And the segment or the fault passed by the continent by specifically close to California, and that's why we have so many earthquakes in this area. So this transform boundary right here called San Andreas Fault split or is a boundary between North American plate on the right side and Pacific plate on the left side. So Pacific plate moves up and North American plate moves this way. Also, you can notice also we have so many transform boundary splitting the divergent boundary right here, for example. One here, one here, one here, so many of them. The example also, you can see them here, for example. beside San Andreas Fault. We have one here, one here. We have so many. Again, they are break the diversion boundary. So again, those are the examples we talked about, San Andreas Fault. And so again, this is how it works. We have here your transform boundary right here. Again, we have plate number 1, plate number 2. Same thing here. We have 2 different plates, 2 and 3, for example, and this basically split or is a boundary between 2 different plates that moves in opposite direction. So looking at this consecutive slide, you see how things work. We have rifting first, and you can see as the plates move away from each other, you can see from this dot right here, the black dot surrounded by yellow color, and this one right here, they will get closer and closer and closer, and finally will move past each other. So let's run this series of slides. You can see how things works. It's moving past each other. And finally, they move away from each other. Basically, they are far away. They pass each other. This can happen to cities along St. Andreas Fault. There are a time, probably 11 million to come, where 2 cities, I forget exactly the one involved, where they will be next to each other, far away from each other, but they will be next to each other, and finally they will move apart from each other. So again, this is our lecture on transform boundary. Again, one thing I have to mention that is important also is that because there's only this motion on both sides like this, the only activity that happen along this transform boundary is earthquake only. There is no volcanoes, there is no mountains, just earthquake. In this transform boundary, there is no creation nor destruction of the crust. Again, remember in diversion boundary, like here, for example, we have creation of the crust. Along conversion boundary, we have destruction of the crust. Along transform the crust. Along conversion boundary, we have destruction of the crust. Along transform boundary, however, there is no destruction, there is no creation of the crust. Thank you.